Hello everybody, I hope today you have prepared and finished the homework what I have given last time. If anybody having any doubts, you can ask me before going to the next article and the most important article of the application of derivative, that is maxima and minima. Okay, you ask any questions if you have. Okay. So now today we will move to the most important article of this application of derivative, that is maxima and minima. So the word maxima and minima is not a new word to you, because those have appeared the different types of Olympiad exams. There the question is asked, find the maximum value of this expression, find the minimum value of this expression. And in the class 11 also you know, the maximum value of the sin x, y is equal to sin x is 1, the minimum value of the sin x is minus 1. That also happen in case of cos. But if you will see y is equal to tan x, just you see the curve, you just think the curve, in the y is equal to tan x, the maximum value does not exist and the minimum value does not exist. So my question is here to say, the concept of the maxima and minima is coming from the algebra or the real number, it is the combination of both. Suppose I am telling a small graph with you. Suppose you take one graph or a function, suppose f of x is equal to x plus 3 say, and I want to see the graph of this function, and that is y is equal to x plus 3. So the slope is 1 here, slope 1 means tan 45 degrees 1, and the y intercept is 3. So 1, 2, 3, and the slope is 1 means tan 45 degree, means the line is making 45 degree with a positive x-axis. You will tell it is your x-axis and that is your y-axis. So this is the graph of the function. So dear students, you see, if you go on right hand side, left to right hand side, the graph will be going on increasing, and it will increase up to what? We don't know. It will increase till infinite, but we have not seen infinite. So if you go to right to left of this function, x-axis, then this graph is going towards there, and it is going towards below of the negative of something. So it is going towards minus infinite. So by seeing the graph, we can able to say the graph or the function f of x is equal to x plus 3 do not have the maximum value. Means the function do not have the maximum value at anywhere. Maximum value we don't know. And you will tell maximum value is infinite, but infinite is not a number. It is just an abbreviation. That is abbreviation because it is more bigger and bigger. So we cannot reach there. Similarly, the minimum value also not exist. So this is the function f of x is equal to x plus 3, where the maximum value and the minimum value of the function does not exist. That idea by seeing the graph we can tell. Suppose you take another graph. Or another function you just consider, say f of x is e to the power x, that is your exponential function. So if you draw the graph, because you see that is y is equal to e to the power x. If you put x is equal to 0, then y is coming 1 because e to the power 0 1. So this is a point called 0 1, and the graph is looking like this. The graph is looking like this. So if the graph is looking like this, again in the same case like this here, if you will see the graph, in this case and in this case. So, where does the function attain its maximum value? Because this will be going on increasing with the increasing of x, and it will be going on decreasing with the decreasing value of x. So, the maximum and minimum value does not exist in this case. Take another example also similar, just a reverse of this function, just reverse of the function you see, say f of x is equal to say log x. Log x means base e. So, that is equal to y is equal to e to the power x, y is equal to log x, and if you want to convert it to exponential function, it will be x is equal to e to the power y. Just the reverse of this function, y is equal to e to the power x. And if you draw the graph of this one, the graph is looking, because if you put y is equal to 0, then x is coming 1. So, it will pass through the point 1, 0. So, it is 0. So, it is suppose 1. So, 1, 0 is this one. So, the graph will look like this. So, it is y is equal to log x graph. Here if you will see, if you will go increasing of the x, the value of x is also increasing. So, you cannot attain the maximum value of the function. Similarly, the minimum value of the function. So, my point is to say that some functions are there where the maximum value and the minimum value does not exist. Suppose you take another cases. Before going to this application of derivative or before applying the derivative, let us see what our mind is saying as per the knowledge of the previous classes. Till the class 11, what we acquired in our mind. Suppose I am taking another example. Say f of x is equal to x square plus 4x plus 7. The question is asked, find the maximum value and the minimum value of the function if exists. If the maximum value exists, you will find out. If the minimum value exists, you will find out. If anything is not exist, you will tell the maxima or minima does not exist. So, see, I can write this function x square plus 4x plus 4 to make it is a complete square. That is plus 3 is there. The 7 I distributed plus 4 and a plus 3. And what's about this? I think it is x plus 2 whole square, then plus 3. X plus 2 whole square plus 3. And you know the square of any number is always positive. So, if the square of any number is positive, so this value, the minimum value of this function, the minimum value of this expression will be 0. And when it will be 0, at that time the value of the function will be 0 plus 3. So, if this value of this expression is coming 0, then the value of the function will be 0 plus 3. Then what is the next value of this function? Greater than 0. If it will be greater than 0, then the value of the function will be greater than 3. Once again I am telling. Though it is a square one, complete square, the minimum value of the complete square is coming 0. So, at that time f of x will be 0 plus 3. So, 3 is the value. And again, this value of this expression will be more than 0. So, the next corresponding value of the function will be more than the 3. That means, the minimum value of the function will be 3. Where? Where it will be 3? When the value of the expression will be 0. So, where the value of the expression will be 0? When this one will be 0. That means, when x plus 2 will be equal to 0. If the x plus 2 is equal to 0, so x is equal to minus 2. So, I can say here at x is equal to minus 2, the function attain minimum value, and that minimum value is 3, and that is 3 is the minimum value. So, my dear students, Once again you see the example. It is a polynomial function. I converted to something complete square plus minus something. And it clearly indicates that this minimum value of the function is 3 and that value is attaining at x is equal to minus 2. So, x is equal to minus 2 is called point of minima, where the function is attaining the minimum value, that is called the point of minima, and the minimum value of the function is 3. So, let us think about this maximum value. So, what is the maximum value? Because you see this value will be more than 0. If this value will be more than 0, so up to what this value will go? Up to what number this value will move? Now, that value will move up to infinite. So, infinite plus something, the answer is again infinite, means the maximum value we cannot attain. So, the minimum value of the function exists, and where it is exist? It is exist at minus 2 and the minimum value is coming 3, but the maximum value does not exist, but maximum value of the function not exists. So, this is the conclusion without applying your derivative, because that type of knowledge we have acquired in the previous classes. Take another example. Suppose I am taking example number 5. F of x is equal to say 3 minus x plus 2 mod. 3 minus x plus 2 mod. Again it is a modulus function. Just take this question in your copy, then you will analyze yourself. You analyze yourself. So, the same question, what is the maximum and minimum value of this function? The question is find the maximum and minimum value if exists. Find the maximum and minimum value of this function if exists. Okay? Analyze this one. You see it is a modulus function, and the modulus function is always positive, and the minimum value of the modulus function is 0. So, this function the minimum value will be 0. Where it will be 0? Now, at x is equal to 2. So, at x is equal to minus 2, at x is equal to minus 2, it will attain minimum value. The minimum value. So, minimum value is 0. At x is equal to minus 2, the function will attain the minimum value. So, at that time, what will the value of the function? Now, the function will be 3 minus 0, that is 3. So, when this expression is providing you the value 0, at that time the function having the value 3. But this value will be more than 0. If it will be more than 0, that amount will be subtracted from the 3. So, the value of the function will be going on decreasing in respect to 3, means the value of the function will be less than 3 gradually. If the value of the function will be less than 3 gradually, so what is this 3? 3 is the maximum value or minimum value. Is there the chance the value of the function will be more than 3? No. It will be more than 3 if this value will be less than 0. And it is less than 0, it is not possible because it is a modulus function. So, here the maximum value of the function, is 3 at x is equal to minus 2. And what is the minimum value? Because this value will be going on increasing from 0 to infinite. So, 3 minus 0 to infinite or 3 minus up to infinite is again infinite. So, the minimum value not exist. So, my dear students, I have discussed 5 questions. It is in your copy, I think. Once again, if you will see all the questions and we will get a impression what's about the maxima and minima. And that maxima minima what you are finding either by seeing the graph or by using our previous knowledge. The first questions I have given one straight line, and in that straight line we have seen the maximum value not exist, minimum value not exist. And the second question I have given e to the power x, there also maximum value not exist, minimum value not exist. Third questions I have discussed y is equal to log x, this is just the reverse of the e to the power x. So obviously the maximum and minimum value does not exist. Again in the example 4 I have given one polynomial expression, and it is a quadratic expression, and by our previous knowledge that the knowledge is square of any number cannot be less than 0, minimum value will be 0 and it will always greater or equal to 0. So we conclude that when x plus 2 will be 0, at that time x is equal to minus 2, means at x is equal to minus 2 the function attained minimum value, because this value will be more than 3 because the plus sign is there. So the minimum value of the function is 3 at x is equal to minus 2, but the maximum value does not exist. Anyone can say, you are the standard 12 students, but I feel so this one in the class 10 students also, they can tell about this because they have the idea about the square of a function. Similarly, in the example 5, I have taken one modulus function. So in this modulus function 3 minus x plus 2 mod, the modulus cannot be negative also. The minimum value will be 0 and this is attending at x is equal to minus 2. So the value of the function will be 3 when at x is equal to minus 2. Henceforth, the value of the function will be going on decreasing from 3. So the maximum value of the function is 3 at x is equal to minus 2. And if we tell about this minimum value does not exist because this value will be going up to non-defined or infinite. So these 5 questions we have discussed before coming to the application of derivative to know the idea what's about maxima and minima. Okay. So these are all about your previous knowledge and the previous idea regarding the maxima minima. So I am just writing what exactly we will discuss in this article. So write down what we will discuss exactly. We will discuss here first local maxima and minima. Local maxima and minima. Second, we will see what is absolute maxima. I am writing maxima as max dot and minima. And the third one is very, very important, that is application of maxima and minima. This is the very important question, and the maxima minima application will be done in the all fields of the mathematics, in geometry, in algebra, in calculus, in your mensuration, maximum application will be mensuration. So this is very important, and every time 1 6-mark question is coming from here, and here sometimes 2 marks or 1 mark questions are coming. So this is a permanent one to get the 6 mark. Okay. So without going to local maxima and absolute maxima, we cannot come to the third point. So I am starting what is local maxima and local minima. So before I am coming to this, I am showing once again 2 graphs. The first graph you just see, and again you realize, and then will conclude. Look at here, I am drawing, this is the graph of a function, and I am taking another graph, say this is the graph of a function, x o x dash, y o y dash. And you see, this is the, if you check about the graph, the maximum value attained here. Here the value of the function is maximum. And what is this maximum value? Now this is the maximum value. And let this maximum value attain at x is equal to x0. So if the function is y is equal to f of x and attaining the maximum value at x is equal to 0, x is equal to x0, then f of x0 is maximum value. Maximum value. So here x is equal to x0 or x0 is called point of maxima. So what is point of maxima? Now the point on the domain or the value of the x where the function attain the maximum value. So here x0 is point of maxima. And f of x0 is maximum value. Write down once again, x is equal to x0 is point of maxima, and f of x0 is the maximum value of the function. So let us come to this function. Here you see, here the function attain the minimum value, because after that it is increasing, Let this point is x is equal to x1. So this is the minimum value of the function. So this is the minimum value, and I will write it is the maximum value. And this is the minimum value. And the minimum value where it is attaining? At x is equal to x1. So x1 is called point of minima. So right here x1 is point of minima. Point of minima. And f of x1 is minimum value. So my dear students, the aim of these two graphs to know what is called point of maxima and a point of minima, what is the maximum value and the minimum value, where the students are usually confused. So you should not confuse. Once again I am telling, where the function, where means at what value of x, the function is attaining maximum value, that is called the point of maxima. And where it is attaining the minimum value, that is point of minima. And if you put this value on the function, what value will come? If it is a point of maxima, so that is the maximum value of the function. If it is point of minima, that is the minimum value of the function. This is the common sense you can apply. Sometimes the students are not applying. Okay. So let us come to what is called, say, local maxima and a local minima. Local. What do you mean by local? Local is, suppose I am a local boy. Local boy means I am belonging to a small area of this particular place. If I will tell Indian, I am an Indian, so it is a big domain. If I will tell I belongs to Odisha, then the domain will be less than the domain of India. If I will tell I belongs to Bhubaneswar, then it is a very small one, and suppose I belongs to Bhubaneswar, then I will be called the local people of Bhubaneswar. So local is a small thing in comparison to the whole domain. So before coming to the local, suppose I am choosing a point A here, that is x is equal to A, and I will take one point the prior to A, means the previous to A. Let this point is A minus epsilon or A minus epsilon, and suppose, or A minus delta I will say, epsilon will be confused little, A minus delta, and in the right of A I am taking A plus delta. So what I have taken? Suppose, so I am getting a interval A minus delta, A plus delta, and I want to discuss the maximum and minimum value with this interval provided delta is very very close to 0. So you just think, if the delta is very very close to 0 means A minus delta, what you are looking in your eye, from your eye, it is not like that, because this length will be very very less than 0, means very very equal to 0 or approximately equal to 0 and tends to 0. So A minus delta and A plus delta is very very close to each other. So that small interval is called local interval. So you see, suppose this point is A minus delta. So A minus delta is here. This is the functional value of A minus delta, and it is the A plus delta. So I can tell it is f of A plus delta, and it is f of A minus delta, and this particular value is f of A. So with respect to the interval A minus delta and A plus delta, the maximum value of the function is at x is equal to A, and f of A is the maximum value, that is called the local maxima. Why? Now before A, if you will see, the height will be less than f of A. After A, if you will see, the height is less than A, less than f of A. Height means the value of the function. So with respect to this interval A minus delta and A plus delta, here the maximum value exists, and that value is called local maxima. So I can say here f of A minus delta, the value is less than f of A. Similarly, f of A plus delta, the value is also less than f of A. So both the values are less than the middle value. So in comparison from this point to this point, so here is the maximum value, and this point to this point is taken as very small interval, that is the local interval. So with respect to the local interval, so the value is here maxima. So this is called the local maxima. Come to here. Similarly, I am taking A minus delta here and A plus delta here, A plus delta here, and this will be the value f of A plus A minus delta. It is f of A plus delta, f of A plus delta. This value is f of A, this value is f of A minus delta. The same way, within this interval A minus delta and A plus delta, provided delta tends to 0. If delta tends to 0, so from this point to this point, there is a very very small distance, and that interval is called the local interval. And in this local interval, the value of f of A is less in comparison to any points prior to it, means previous to it, and any point after it. So this point A is called local minima, and f of A is called local minimum value. So here I can say f of A plus delta is greater than f of A, and similarly f of A plus delta is also greater than f of A. So any value within this A minus delta and A plus delta, that must be greater than f of A. Any value between A to A plus delta, that will be must be greater than f of A. So among all these values, f of A is the minimum value, and this value is attaining at x is equal to A. So I can say here, in this case A is the local minima, and in this case here the A is also the local maximum. Okay. So you got what is called a local maxima and a local minima. But you see, for some functions there may be more than one local maximum point or more than one local minimum points. So what I am telling, for some functions are there where the local maximum points will be more than 1 and local minimum point is also more than 1. Take a very simple example, y is equal to sin x. And draw the graph of it, that I am showing how the functions may have more than one maximum value, more than one local maxima points and more than one local minima point. 0, it is a pi by 2, it is pi, it is 3 pi by 2, it is a 2 pi, here say minus pi by 2, it is a minus pi minus 3 pi by 2. So, the maximum value attaining at pi by 2, minimum value attaining at 3 pi by 2, and here also the minimum value attaining at 3 pi by 2, and the maximum value attaining, if it is 2 pi minus, again the maximum value is attaining there. So, you see, we add pi by 2, it has the maximum value. It has the maximum value. And at minus 3 pi by 2, it has the maximum value. And at minus pi by 2, minimum value. And at plus 3 pi by 2, minimum value. And you know, the graph of the sine will be going on like this way. So, you will get infinite number of local maxima. And you will get the infinite number of local minima. So, this is the conclusion. Write down. I am just calling. A function may have more than one local maxima point or more than one local minima point. Okay? Okay. So, whatever it may be local maxima or it may be local minima. Now, we will see the working procedure, what we will get, how we will get or how we will find by applying the derivative, how we will find the local maxima and a local minima. Working procedure. Look at here. Once again I am drawing the same graph, because this concept is like that. And here you see, this is the maximum value at x is equal to a. Similarly, suppose this is the minimum value at x is equal to b, suppose I am taking. So, x is equal to a. So, if you go to the curve, there the tangent is parallel to x axis. So, this particular point is called the extreme point. So, what is extreme point? Write down what is extreme point. Extreme points. The points where the function will give or will provide the maximum or minimum value. The points where the function will provide the maximum and minimum value, these are called the extreme points. And it is also called the turning point, because this function is turned here. This is also called the turning points, or it is also called the critical points. So, for this article, let us assume let us discuss it is an extreme point. So, my dear students, you just see here, this is the point of local maxima, and exactly if you go to the curve, you will get the tangent is parallel to x axis. Just before that, you see the tangent is looking like this, means the function is increasing. So, at x is equal to a, here how will get now dy by dx is equal to 0. But here you will get dy by dx is greater than 0, because it is increasing. it is increasing and it is going there and attaining the maximum value. Then the function will decrease. So in this pad, the function will decrease, means dy by dx will be less than 0. So my point is to say how to get the local maximum. So first what we will do? We will find dy by dx and we will put dy by dx is equal to 0. So when you will put the dy by dx is equal to 0, so I will get the points where the tangent will be parallel to x-axis. And x is equal to a is one of the such point where the tangent is parallel to x-axis. So x is equal to a is what type of point? The local maximum point or local minimum point? And it is understood is local maxima. So before the local maxima, the function nature is increasing, means derivative greater than 0. And after this point, the derivative is less than 0. That means if the derivative of the function changes from positive to negative through this extreme point, that extreme point is called local maxima. I will call all these things, but you try to understand here. And here you see, here the derivative is or I will say f dash x. F dash x is equal to 0 here. So the derivative is 0 here, and here the function is decreasing. So derivative of the function is less than 0, and after that is increasing, derivative of the function is greater than 0. That means if the function or if the derivative of the function changes from negative to positive through the extreme point, then that extreme point will be local minima. So write down the points, what I am calling the working procedure, how to get the local maxima and local minima, and what we are using. Now we are using the first order derivative test. Write down the first order derivative test, how we will get it. Write down the first order derivative test. So let us see what is the step 1. Step 1, find f dash x and put it 0. Let the values of x is equal to x1, x2, x3 dot xn, which are the extreme values. Point 1. So by putting the derivative is equal to 0 and we will solve for x, what value of x will get? These are the extreme points, means where the function may attain local maxima or may attain the local minima, and these points are here x1, x2, x3, xn. Correct? Then put the x1, x2 dot xn on number line. On the number line. That is put the on the number line. That is making one number line. So suppose 0 is here, x1 suppose, x2 suppose, x3 suppose, like this. How many extreme values are there? Put on the number line. Point number 3. Point number 3 you see. If f dash x changes from positive to negative through x1. Suppose here is x1. The point is x1 here, and before x1 this derivative is positive, and after x1 till the next extreme point the derivative is negative. So that I want to say, if f dash x changes from positive to negative through x1, then x1 is local maxima. You see, if the positive to negative, this is the local maxima. Similarly, the fourth point I can write here. The fourth point write down. The fourth point, if f dash x changes from negative to positive through the point suppose x2, through the point say x2 within bracket say means assumed. So here positive negative, it is negative positive. So if the derivative of the function changes from negative to positive, you see this is negative and this is positive. You see this is negative, I can write here immediately, let this point is x1 and let this point is x2 and other things I will let this point is x1, let this point is x2. So here it is changing from positive to negative, local maxima. Here negative to positive, so local maxima. Then x2 is local minima. So these 4 points I called, these are the working procedure and how to get the point of local maxima and local minima. After getting the point of local maxima and local minima, if you put those values on the function, that corresponding function value is the maximum value, means like maximum local value and a minimum local value. So I think I covered till the first order derivative test, and what we have done today, just I am recapping in the 2 minutes. I first discussed what's about maxima and minima with the previous knowledge without using calculus. Then we divide what are the articles, they are in the sub-article of application of derivative. And using the graph we have seen where the maximum values exist, where the minimum values exist. And we discussed about the local maxima and the local minima. And by observing from the graph, we have written the working procedure, the 4 points, how to get the point of local maxima and point of local minima. So I think, I hope you understand all this concept what we discussed. This is the first class of the maxima and minima, and today we are not able to solve any problem, but I have given 5 good examples to showing how the maximum and minimum value of the function exist in different type of functions. So thank you very much once again for your patience hearing, and I am not giving any homework today, but tomorrow definitely we will solve some problem. But it is my request, before coming to the solving the problem, what are the working procedures, what are the last 4 points I have told you, please recall all those 4 points, and using these 4 points, next class we will discuss some problem based on local maxima and local minima. Thank you very much.